Hi everyone. So in this video, we will analyze the paper SafeLLM, Unlearning Harmful Outputs from Large Language Models Against Jailbreak Attacks, which is a new method designed to remove harmful behaviors directly from the model's memory. Now, why this paper matters? Because this paper answers a critical question every company is asking. We know models can produce unsafe outputs, but how do we get that rid of those behaviors without destroying model quality? Traditional safety techniques either add heavy filters, censor too much, reduce helpfulness, slow down the model, or fail under iterative attacks. Safe LLM offers a different approach that instead of blocking the model, it modifies the model so it forgets the dangerous behavior entirely. So think of it as a target unlearning, not blanket refusion. So let's understand this paper in most simplest way possible. It's a LLM security paper and it's published in 2025. So let's get started. So here, this is the paper. Basically, this paper is about the safety of this large language models. Before starting this paper, imagine a giant brain that learned from the entire internet. Most of it is helpful, answering questions, solving problems. But deep inside that brain, tiny hidden pockets remember things we don't want it to say, like harmful instructions or toxic language. And attackers have figured out how to poke those pockets with clever prompts called jailbreaks. So, this paper Safe LLM shows how to find those harmful pockets inside the model's brain and erase them cleanly without damaging the model's intelligence. Let's walk through the entire paper step by step in the simplest way possible. So, here we will start with the abstract. So, this paper starts by explaining its main message that language models can still be tricked into giving harmful answers using jailbreak prompts. So, the author proposed Safe LLM. That is a method that makes the model forget the exact harmful memories that produce unsafe text. Safe LLM does three things. First, it detects when the model's output is harmful. It finds the exact token and the exact internal part of the model that produce the harmful behavior. It removes that harmful behavior using a small careful update. So the model forgets the harmful part but keeps everything else. So the experiment shows that this method reduces jailbreak success dramatically while keeping the model's ability strong. That's the big idea in one sentence. Remove harmful knowledge without hurting the good knowledge. So here, when we will read this paper, we can just see what this they have done. Like they have used the three-stage pipeline: dynamic unsafe output detection using hybrid approach, and token level harmful content tracing, constraint optimization, and then they have shown that they are working better than other LLMs. After this, we come for the introduction part. So here, large language models are powerful. They help us write, answer questions, learn, and automate tasks. But they also have a weakness that they sometimes say harmful things, especially when someone tries to push them. Jailbreaks are the prompts designed to trick the model into ignoring its safety rules. People say things like pretend you are evil, or hide harmful instructions inside long stories, or use tricky formatting. Even after we train the model to be safe using things like reinforcement learning with human feedback, new jailbreaks keep appearing. So, safety training alone is not enough. So, this paper suggests a new approach that instead of fighting jailbreaks at the prompt level, go inside the model's internal memory and erase the harmful pathway directly. And this is the core motivation for Safe LLM. That is, they have shared here that to address these challenges, we propose Safe LLM that combines dynamic detection with unlearning techniques to unlearn the harmful knowledge while preserving core functionality and linguistic fluency. So after this, let's understand the complete paper. So we'll start with the related work. So here the paper reviews earlier jailbreak attacks that people have invented many clever techniques like prompts that are written like stories, prompts that use logic tricks, the prompts that use weird sequences of symbols, prompts that are generated by another AI, prompts that paraphrase harmful questions so that they look safe. And the message is simple: jailbreaks adapt fast and they come in many forms. So we need a defense that don't rely on fixed patterns or keyword detection. So here in the related work, they discussed about this jailbreak attacks, what all jailbreak attacks are. Then they discuss all the defenses, what the jailbreak defenses are, and then they shared the motivation and the message. Then comes the related defenses. In the defense part, they say that some defenses block harmful prompts before the model sees them. Some rewrite the prompt to remove harmful meaning. Some use strong system instructions. Some use extra safety training. Other methods tries unlearning, making the model forget certain behaviors. But most current unlearning methods either forget too much and hurt model quality or forget too little and harmful outputs come back. So safe LLM aims to be more precise, removing only the harmful memory that produce unsafe text. So after discussing this jailbreak defenses, they shared that recent advances, what they are saying, what recent studies are saying, and how their method is different here. Like, unlike this unlearning based defenses, safe LLM performs a fine grained token level unlearning by tracing and suppressing the activation pathways in fully connected layers responsible for harmful token generation, which enables precise removal of unsafe behaviors without degrading the model's general language capabilities. Next comes the background. So here this section introduces the idea of key value memories in transformer models. So inside each layer of the model, there are many tiny memory pairs, a key that gets activated by certain patterns and a value that controls what the model says next. So only a few of these memory pairs are responsible for harmful outputs. So instead of changing the whole model, we can find the exact few memories that cause harm. So idea is important because safe LLM uses it to accurately locate harmful behavior. So they have shown the importance of this key value memory networks and how we can use them to accurately locate the harmful behavior. So they have discussed about this memory mechanism here and the safe LLM method. So in the safe LLM method, this is how it actually works. So here this is first detect harmful output. That is, first safe LLM checks if the model has something harmful. It uses two signals, an external toxicity classifier and the model's own judgment. And these are combined into one score. If the score is high, we treat the output as harmful. Then in the step 2, find the harmful token. That it finds the exact token, the exact word that made the output unsafe. It measures how much each part of the model contributed to it, and it picks a token with the strongest harmful influence. So this way the unlearning is very specific. And in the step 3, like step 1 is harmful response detection, step 2 is harmful token tracing, and the step 3 is find the harmful layer. So the safe LLM figures out where in the model the harmful memory is stored. So the method temporarily removes each layer one by one and sees how much that produces the harmful tokens probability. Whichever layer causes the biggest reduction is the layer that stores the harmful pathways. And the step 4 is unlearn that harmful memory. Finally, safe LLM performs unlearning, so it updates only the harmful layer and only the harmful memory units inside that layer. It is like doing a surgery with a laser. Remove only the bad part, leave everything else untouched. And the update is constrained, meaning it tries to change as little as possible while still removing the harmful behavior completely. So when you will read this paper, so just look that way. Safe LLM, like they have discussed their algorithm first, the maths, how they are using this constraint optimization in the end, and other things. And then the first harmful response detection is there. They're talking about this. And then this is the steps that they have shown harmful uh, detection. The first is a prompt input. Then second step is harmful detection. Step 3 is harmful token tracing. Step 4 is harmful knowledge removal. And the step 5 is benign, final benign response. Okay, by just doing the surgery using laser that way. So if any paper has a workflow or the diagrams, then the understanding becomes easier. So let's understand this experiment part. So here they have shared all the setup, like how they have discussed the baselines, And here, author tests safe LLM on multiple models, Vicuna, LLama, 2BGT, and GPT. So they evaluate it on harmful data sets like Bench, Strong Reject, GPT Further, plus many paraphrased harmful questions. And they test normal abilities using Open Book QA and Truthful QA. So they measure two things: does safety improve? And does the model stay useful? So here they have shared exactly what data sets they have used to verify the things. Okay, so here what they have taken, they have shared that thing. So this way we can read it, and then there they shared the baselines. And after this, they discuss the results here, and the results are strong. That if we discuss this results, the safe LLM reduces jailbreak success rates dramatically. In many cases, down to nearly zero. At the same time, normal performance barely changes. This means the model stays smart, helpful, and knowledgeable. And also, after unlearning, harmful outputs becomes very unlikely. Their probability shoots up, showing the model has truly forgotten them. So this way, we can check how their results are better. And then they have shared the data sets, query their responses, test data sets that they have shown here. And after this here verification, after unlearning, they are checking that thing. And then comes this most important part is the ablation study. So this paper tests variations of the method. They show that dynamically balancing the harm scores works best. They also show that the strength of unlearning constraint matters. Too small and forgetting is incomplete. Too large and the model loses useful knowledge. So their chosen approach gives the best trade-off. And finally, we discuss this conclusion part here. So, in the conclusion, the paper ends with the main message that Safe LLM introduces a precise way to remove harmful behavior from language models. It detects harmful output, finds the harmful token, locates the harmful internal laser and or the layer, and erases that memory without damaging the rest of the model. So this approach makes jailbreaks much harder and keeps a model safe and reliable. It shows that target unlearning is a strong, promising direction for building safer AI systems. So, as this the paper is LLM security paper, and in every LLM security paper, we normally use a rubric system so as to understand whether the paper is actually useful or not. So, for this rubric part, first we check is a threat here. So here, what threat is safe LLM defending against? So this safe LLM assumes a realistic and common threat. Attacker is an external user. They only have text prompt access. They try to jailbreak the model. Then they try to extract harmful content. They may use many attempts. They may use rephrasing, translation, reasoning. They may use optimization technique, but they cannot access model weights or logs. This is exactly how real world attackers behave. Now, why this matters? Because Safe LLM is not built for unrealistic or exotic attackers. It's built for everyday jailbreak attempts, the kind that shows up in custom systems and internal deployments. After this, we understand what is the attack surface here. Like attack surface is what unsafe behavior is Safe LLM trying to remove. Okay. So here we will understand whether this paper is able to do or not. So here Safe LLM focuses on outputs. So meaning harmful advice, unsafe instructions, sensitive operational details, illegal dangerous process, toxic content, policy violation, restricted knowledge, jailbreak responses, disallowed action. It does not just block this at the surface. It tries to delete the underlying behavior. So think of it like removing a faulty memory from the model, not putting a sticker on top saying don't use. Okay, then comes the method part here. So here the safe LLM part. So how does the LLM work? This is the heart of the paper. So when we compare this as per the rubric part, the first step is identifying what harmful content the model can produce. And this is done by testing the model with known jailbreak prompts, adversarial questions, reasoning shift prompts, tricky edge cases, policy bound scenarios. And the goal is to collect examples of harmful outputs. Simple way to think about it is just create a list of specific things the model should not say. And the step two that they have shared even here, that trace the unsafe behavior inside the model. And this is the innovative part here. The authors try to find which part of the network are responsible for producing the harmful knowledge. They examine attention hits, feed forward layers, specific activation patterns, neuron clusters, intermediate reasoning steps. So when harmful behavior appears, certain components activate strongly. So think of this as isolating the problem neurons. And the step three, apply targeted unlearning. So once the harmful patterns are located, safe LLM applies a technique to weaken or remove them. So the key idea is you don't change the entire model. You only adjust the problematic part. And this is done using a constraint optimization method. In simple terms, the model is trained to forget specific harmful knowledge without forgetting everything else. Step 4 is preserve the model's usefulness. So, unlearning can accidentally break helpful behavior. So, the authors add a balancing technique that penalized harmful behavior, reward normal, safe, useful behavior. This keeps the model helpful and coherent. And it's not enough to remove bad behavior. We must keep the good behavior intact. And then the step 5, test whether jailbreak still works. So the author run jailbreak attacks or modified model. They check can the model be tricked, do iterative reasoning, attacks still succeeds, do multi-step prompts break it, does the model reconstruct harmful knowledge indirectly? This ensures the harmful behavior does not return through clever prompting. And then we normally check for the evaluation parts. Here in the experiments, results, we check whether it was tested properly or not. So if any of this rubric is missing, normally it's not considered good paper. So that's why we are checking whether this paper has all these things or not. So here in this experiment, Safe LLM was tested on several large language models and different of the different sizes, multiple safety categories, thousands of prompts, adversarial test sets, real jailbreak attempts, translation attacks, role-based prompting. And they compared against baseline safety aligned models, reinforcement learning based safety, output only filters, soft refusals, strong refusals. And this broad evaluation shows that method is not one of trick. The safe LLM consistently reduce harmful outputs without major loss of helpfulness. And then we normally check for this methods and the results. Okay, so in this methods and results, we check what were the outcomes. So the key significant results are significant reduction in harmful outputs across multiple models and categories, lower jailbreak success rate, that is, attackers struggle to bypass unlearning even with iterative optimization. The model remained useful, journal reasoning, communication, and knowledge stayed strong. Less of a refusal means the model didn't turn into a no bot that refuses everything. No major drop in accuracy means the tasks unrelated to the harmful behavior were unaffected. Better robustness under multi step attack. And this is crucial because models stay safer even when attackers try long conversation. And this is what organizations want, not a paranoid model, not a reckless model, but a balanced one. Then normally we check for the failure analysis. So here in this failure analysis, we check where does this model struggle. Because no research is perfect. If it won't have any drawbacks or limitations, how will we work in the future? So here the author points out several limitations that deeply integrated harmful knowledge is harder to remove, or the very large language models may regrow the harmful pattern through reasoning. Some harmful concepts are too intertwined with normal knowledge. Long reasoning chains can still expose weak spots. Unlearning can slightly weaken rare but legitimate tasks. Unlearning does not block all forms of jailbreaks. Repeated long term conversations will still require monitoring. And this shows the paper is realistic. They acknowledge that unlearning is powerful but not perfect. So we have this open problems to solve. And if we talk about what's remain open, so here we will talk what are the future directions. Suppose I want to work on the gaps in the paper. So here this paper highlights some future directions that unlearning must become dynamic, not static. Models should detect when reasoning drifts into unsafe territory. We need better tools to locate harmful knowledge inside large models. Safety should be embedded into reasoning, not afterward. Agentic workflow needs special safeguards. Multi-turn conversations require deeper defense. Combining unlearning with other defenses is necessary. And this is useful because it shows where the field is heading. So if we have to conclude the complete paper, so we can say that SafeLLM is not a filter. It is not a wrapper. It's not a refusal engine. It is a method that finds harmful internal behavior, removes it from the model, preserves helpfulness, increases jailbreak resistance, works across multiple models, complements modern safety strategies. And this paper shows the future of defenses, that is, modifying models from the inside, not just blocking bad outputs from the outside. Hope this paper is clear to you. So next time, whenever you read a LLM security paper, so understand the paper this way. Thank you.